Hello, my name is Roshan Katel and my UN ID is 154222182. This is the video demonstration for my dissertation. I have done my dissertation on the topic sales forecasting in inventory management system. In this project, in this research, what I have done is I have tried to work on the machine learning model that forecasts the future sales of any item in the inventory management system. What I have done to be in detail is I have tried to make a machine learning model in Python, and then I've, I've implemented that machine learning model in a web-based inventory management system, so that the inventory management system takes the data from the web application and then keeps it in the database, and then that sales data can be further used to feed the machine learning models after a certain time interval. Uh, at first, let me show the machine learning model here. Uh, the data sets for different items have been collected from the different online sources like Kaggle, Google Datasets Provider, and even from the local stores available. So at first, let me show the model I've worked on. At first, I tried different simple algorithms, linear algorithms, decision tree, and all those things. But those simple algorithms could not predict or could not find the value very near to the actual sales, because the actual sales contains a different factor like seasonality and trend, and different those factors present in the data makes it very difficult for the simpler algorithm to forecast the sales in the of the future. So it's a kind of a time series problem. It's been a kind of a time series problem. So the data set basically contains the sales of a item in a certain time interval, and then I've collected those data and then tried to work on it. So let me first show how the model has worked in the Google Colab. As we can see in this screen, this is the model code of the model in Python, and this what it does is I have this is the way we read the CSV file. This is the CSV file present here. This is the data set actually, and then for the cleaning of the data has been collected from the different online sources, as I have already mentioned. And now what we do after the collection of the data is we clean the data. We read the data and then we clean the data. The data here we have tried to make only two columns, that is month and the sales. That means the sales column and the month column. And then in the second step, what I have done is I have tried to check the null value present in that data set. If there is a null value present in that data set, then those data will be dropped. So that is what I have done in this step. Now, since this is a time series model, we need to make sure that the timeline column in this data set are in the date time format. So the month is the date column here. So we set the index to date time, pd.to date time. That means this column has been now date time. So we set this index as month, and then what I've done here is I've tried to plot how the actual data looks. Let me show how the actual data looks here. Let me run this. Okay, it's running. Okay, so this graph here, okay, sorry, I'm sorry. Okay, this graph here shows the actual data. This is how the actual data flows. Now let me again go up and continue. And then what we have and then from this graph, what we can see is that from 1964 to 1965, in between somewhere here, the graph has gone up again. In front of 1966, 1967, the graph goes up. That means the peak rises. Now from this graph we can clearly understand that the data has a seasonal nature of sales. That means the item sales grows at certain point of time in a year and then goes down at certain point, and then again in the next after 12 months the peak again rises. That's how this data is showing us. So we need to consider the fact that this data is a seasonal data. Now what we do is we make the data, we check the stationarity of the data. To check the stationarity of the data, we do Dickey-Fuller test, and for that we have imported all these things, Dickey-Fuller test. And now till the time we check for the stationarity of the data, and then if that data is not stationary, then we do the differencing. differencing to make the data stationary. So here we have done differencing for a single time, and then after doing for the differencing for the single time, the data became stationary, and then we have plot the graph after the data has become stationary. Now this is the graph that shows a kind of a stationary data. Now the Dickey-Fuller test has shown this graph data as the stationary data. So after the Dickey-Fuller test gives us the permission that the data is stationary, then what we do is we go and plot the partial autocorrelation and autocorrelation graph. These are plotted to find the value of the autocorrelation and the moving average value. Since we are using ARIMA model, ARIMA is auto-regressive integrated moving average model, and because of the seasonality present in our data, we use the SARIMA model, that is seasonal auto-regressive integrated model. So this model is used here. Now for that, what we do is we need to find out the value of auto-regression and moving average. For that, we plot these graphs autocorrelation and partial autocorrelation. So from them our seasonal differencing has been 1, and from them we find out that the value are 1 and 1 thing. So now what we do here is we import this model, SARIMAX model. On that model we feed our sales data, past sales data from data frame. This is the thing, and now our order is 1, 1, 1. That means moving average, auto-regression, and then the seasonal differencing. This is the thing. And then again seasonal order is the first 3 are the same, auto-regression, seasonal differencing, and then moving average. And this is 12 means how many date index or how many index of the data has to be taken for the seasonality of the data. That means after how many data sets the seasonality occurs, that is 12. So we have put here 12, and then we forecast the sales, and then we plot the graph and then see this. So now the SARIMA model actually performed very well. I have tried many other models to work for this data set, but those could not work fine, and SARIMA model worked the best. We can see that the yellow line here is the forecasted value and blue line is the actual value. So the yellow line somewhat goes along with the blue line. That means we can understand that this is considerably a good model for the prediction of these data sets. Other simpler models or other form of model, I have tried many. I have tried Holt-Winters method, I have gone with a simple ARIMA model, I have gone with other moving averages model and many other models, but those could not work as good as this model worked for this dissertation. So I have used SARIMA model for this purpose. Now this is how the model is made. Now another challenge to complete in this project is to implement this machine learning model in a web-based application. So for that I have built a backend system for basic inventory management system in Python Flask. Flask is a Python web framework, and then I've exported the REST API from that backend, and then I've used React.js for visualization of the data. So let me show a little bit about that also. That's how I've implemented this research. Okay, sorry. I'll show that. Okay, this is the source code. So let me start running the project. Sorry, cd backend c source bnb/bin/activate ls python app.py. Okay, the backend engine is now running. Let me run the front-end engine first, and then I'll explain. Okay, start. So now, how I've implemented this machine learning model made in Python in a web-based application is I'll show from here, front end, back end. Now, for example, I have made this is one of the model. This is one of the model that forecasts the sales for the shampoo. Now I have made this model. This is the model that I have shown earlier in the Google Colab, and at the end, what I have done is I have used the package joblib from Python to export this model in a pickle file. Now this pickle file contains the trained model, and then the Flask app or the backend engine, what it does is it calls this pickle file and then load it, and then it forecasts and then it gives the predicted value from the point where the data, after the point where the data lies, as a this in a JSON format that is exposed as a REST API. So front end calls the REST API to get these predicted values. Now I will show now this is how the machine learning model has been implemented. So this is how the pickle file is loaded, and then the JSON value is returned, and then REST API has been exposed in this way. So and then front end engine calls it the React.js. So let me run the project and then show from that point. Okay, so let's log in first, because of since there is a authentication also. Let me log in first. Admin. Okay, now this is the dashboard of the front end engine. I have showed a little details about the items present here, and then the total sales. Total sales of all the items of this week is shown here. So this front end engine, what it does is, let me first it does all the CRUD operation. That means we can add an item from this visualization. Since the video is going to be too long, I'm not going to add all those things, and these are the items present in the inventory. For example, let's consider item cold drinks. Okay, these are the details of the items, all the things, and we can edit its record from here. We can delete this item also, and then what we can do is we can make the sale of an item. Okay, we can now the cold drinks unit is bottle. It's available in bottle. Sales price is this and all. Now we sell the bottle things. Now item sold successfully. Now this is how the sales is recorded. Cold drinks sold this many, unit, selling price, and on this time stamp. Now what we do is we record the sales in this way. Now this means on this time the sales of cold drinks has been done. 4 bottle of sales cold drinks has been sold. So this is how the sales database is recorded, and then after a month interval time, this data is exported in a CSV file, and then that data set is used to train the model, and then again the pickle file is renewed after a certain interval of time. Now this could have been made automatic with the salary and all job scheduler applications, but because of time constraints and all those factors, I could not do it immediately, those automatic things, but still I tried my best to do it, though it's manual. Now on this way, the sales details are recorded here, and items is shown here. Now what I have done is prediction. That means cold drinks prediction after the available set of data. Now this graph shows the sales of the future data after the sales record. Since the data recorded here are older ones, so the date here are also very old, but this is how the forecasting is done. So the data set present here are till the date just before October 1972, and so here the prediction has been made from October 29, 1972. This is how the prediction has been made. So if the data is renewed or recorded, or new data is given input to the system, the new forecasting values are then shown. Similarly, in this way, the shampoos prediction is also shown in this way. And whatever item is added to the system, and if its past historical sales is added to the system, this gives the visualization. This gives us visualization about the future prediction. This is how the implementation of my dissertation I have done it. Beside making the machine learning successful machine learning model, I have also implemented it on the web-based inventory management system. The source code, all those source codes will be attached in the zip file, and these are the source codes. This is how the front end works. All these things I have showed very briefly about this implementation. because of time, because this video is going to be too long. And then another thing is this is my documentation. I've written all the details of how the data were collected, data were prepared, models. Why did I select that model? A lot of work has been, though I should talk very briefly about the model selection here because of time constraint in this video. I've done a lot of research and I've tried to work out with many models to before I actually choose these models, but none of them performed as better as this model. And then all the design, functional design, implementation, testing, and all these things, and the potential development that could have been made further are attached in this document. So this is how I've tried my best to work on the machine learning model, implementation of machine learning model for sales forecasting, and then its implementation in the web-based application. Thank you.